Hello everybody, this is Todd Frazee, and this is the DES2 Unit 5 lecture on auxiliary views. Auxiliary views are orthographic views that are projected onto any plane other than the one of the 6 principal views. The purpose of an auxiliary view is to display the true size and shape of a feature on a plane that occurs oblique in relationship to the primary 6 orthographic views. Auxiliary view projection theory relies on the projection of line of sight lines perpendicular to a plane using one of the two methods. First, the folding line method, and second, the reference line method. The fold line method uses the same glass box projection theory used for the standard 6 orthographic views, except that the plane of projection is parallel to the face to be described by the view. The view spacing of the auxiliary view using this method is the same distance as the standard views in reference to the frontal plane. Now let's go to a real life example. And for our example, since Halloween's coming up, we're going to use a pumpkin. And we put this pumpkin in an acrylic box so we can draw each view. Top, front, left side view, the back view, and the right side views to describe our pumpkin. Now if we were to unfold the box, this is what our orthographic views would describe to detail out our pumpkin. Now wait a minute, let's back up. You see our pumpkin has a flat spot in it with a round feature in it. We're going to want to describe that feature. So how do we do that? This is where the auxiliary view comes into play. If we want to show the true shape and the true size of the flat, we need to first make a plane that's in the same plane as the oblique feature. We then can look directly and project view-point lines from the feature onto that oblique plane. Then we fold the oblique plane down to produce our auxiliary view where we can dimension things in real size. In this example, it's a partial auxiliary view because it is only displaying the surface of the oblique plane. Happy autumn, and now we need to get back to work. The second method for projecting an auxiliary view, the reference plane method, follows the same line of sight principles as the fold line method, but the view placement is determined by a reference plane on the object rather than the frontal plane, and the view placement is independent of the adjacent views. There are several guidelines for the creation of auxiliary views. First, reference or fold lines are always drawn perpendicular to the projection lines between the views. Second, transfer measurements are always taken parallel to the projection lines and perpendicular to the reference or fold lines. Third, reference planes always appear on edge as a line in the views adjacent to the central view, but never in two adjacent views. Fourth, distances from the object to the reference or fold line in the auxiliary view and measuring view are the same. Auxiliary views can be projected from each other, which results in a classification denoting the level of separation from an original standard orthographic view. The primary auxiliary view, which is a single view that is projected from one of the 6 principal views. A secondary auxiliary view which is a single view that was projected from a primary auxiliary view, and the tertiary auxiliary view, which is a single view projected from a secondary or another tertiary auxiliary view. Reduced detail auxiliary views are very common in the form of partial auxiliary views, which omit hidden lines and details other than the inclined plane surface. The example on the right shows an example of a full auxiliary view, and on the far right, a partial auxiliary view example of the same angle of projection. Half auxiliary views, like the example on the right, are also permitted for describing symmetrical features on an object. This concludes the lecture on auxiliary views, and I'll catch you online.